Sir, start. We can start, sir.
Okay, Pratik, if you want to start, you can start
Yes,
off
yes.
the introductions. And after
Sandeepji,
the
shall
slides
we start? Yeah.
Yeah.
Sandeepji, shall we start?
Yes, Pratik.
Okay, okay. Good evening, everyone. Today we have gathered here for the live session on the course Energy Resources, Economics and Environment. We are in the 9th week of the course. By now, we have looked at in week 1, we saw energy flow diagram, global trends, and Gaia identity. Like things in week 2, we talked about energy and quality of life, inequality, energy security. In week 3, it was about energy economics. Week 4 was about resources and reserves, growth rates, and we looked at peak oil concept, Hubbard's model. In week 5, we talked about materials used in renewable energy, non-renewable energy economics. In week 6, we talked about preference and utility. In week 7, we talked about public and private goods and BADS, demand curves, externalities. Week 8 is about financing energy, and week 9, which is we are in, is about input output analysis. So we are conducting this live session to resolve the queries if you have any, and there are few things which need some re-evaluations. We are doing re-look at them. So we are doing this with the help of live session. So I welcome Professor Banerjee, Prabhat, and Sandeep Yadav, who are also like Professor Banerjee is a course instructor, and Prabhat and Sandeep along with me we are teaching assistants. So I welcome all of you, and maybe we'll start with the introduction with this. So
Good evening. My name is Rangan Banerjee, and this is, of course, a recorded course, but Pratik, Prabhat, and Sandeep have been interacting with you through the assignments and also with some help sessions. This is also a help session. We'll also take some time to, depending on the time available, also talk about energy transitions and the net zero concept. So I'd like to ask each of the TAs to introduce themselves. Pratik,
yeah.
maybe you can go ahead.
Yes. So good evening, everyone. I'm Pratik Joshi. I'm PhD student at Ashang Desai Center for Policy Studies, IIT Bombay. I'm working on deployment of rooftop PV systems in India, and I'm teaching assistant for this course. Sandeep.
Yeah. Good evening, everyone. My name is Sandeep Yadav. I'm pursuing my PhD in Energy Science Engineering Department, IIT Bombay, and I'm researching on the cold energy utilization of LNG regasification process. I am the one of the TA in that course, and I'm also taking the live sessions or weekly problem solving sessions for you in the every week. Thank you. Prabhat, you can go ahead.
Hi, good evening, everyone. My name is Prabhat Sharma. I'm also a PhD student in Energy Science and Engineering Department, IIT Bombay. My topic of PhD is like reducing the cooling load of buildings for occupant comfort, and I'm TA for your course.
So we'll start with any queries or questions that anyone has posed. Pratik, do we have any questions already earlier?
No, as of now, no. But we are tracking it live on YouTube. So if
Okay.
anyone has any comment, maybe they can put it in comment box. We will take it after the presentation.
Okay. So if there are no questions, let me just give a quick introduction about, we are currently in the world, we are looking at the transitions in the energy sector. And these transitions are mainly, as we have discussed in the course, have been mainly driven by climate change. So when we think in terms of energy transitions, most countries in the world are now focusing on how we can go towards net zero. So if we look at this, they're not moving.
No, we can see title slide only.
So I need to, I guess I'm sharing the file. Should I?
Maybe we can try unsharing and sharing.
Yeah, I'll unshare it. share my screen. Is this happening now? Can you see? Are you able to see it?
Yes. Yes, maybe you can try changing the slide. We can see the title slide.
Yeah, so as we discussed, we have talked about the Kaya identity. So when we look at the country as a whole, we look at the CO2 emissions and we look at the options that we have. And we talked about two different factors, the carbon intensity of the economy, and we can improve or reduce the carbon intensity of the economy by going for energy efficiency, by going for renewables, by going for nuclear carbon sequestration. And we talked about the energy intensity of the economy, which we can do by changing either the structure so that we don't do the energy intensive industrial sector, we go more towards services, or we look at energy efficiency. We also can think in terms of carbon capture and storage, and all of these options are available. If we want to go from the CO2 emissions that we have, typically each country is going to try to increase its GDP per population. And as we have growth in the GDP, and there will be also some growth in the population, we can try to stabilize the CO2 emissions and take it towards net zero by making the carbon intensity, reducing the carbon intensity and reducing the energy intensity. So we have tracked, and you've seen some of these numbers before for the world. For each of these factors, you can see how things have been changing over time. And the plan essentially is to look at the current trend in CO2 emissions. And we have various options where we can see, if you look at all the policies that we have been stated by each of the countries, if we go in that way, that will reduce from the current trends, but it will still be increasing. We want to actually go towards a sustainable development scenario, which means we will do a whole host of things: efficiency, renewables, fuel switching, carbon capture and storage. We can use the carbon intensity and the Kaya identity and look at each of these factors, how they've changed over time, and also see how we can make them change in the future. So we can create possible scenarios. This is the Kaya identity components for India. And we've already discussed this, the options, mitigation options, increasing the sinks, reducing the sources, afforestation, fuel mix, efficiency, renewables, nuclear, carbon sequestration. And this is the McKinsey curve, which is the GHG abatement curve. On the x-axis, we start with looking at how much CO2 emissions we have today. And in a business as usual scenario, how much would that result in a target year, let's say 2030. If we want to reduce it by a certain amount, each of the but each of the lines on the horizontal axis, we see how many million tons of CO2 per year can be saved. And you will see that many of the initial options, the efficiency options, are actually at negligible costs and at negative costs. And then you have the higher cost ones, some of the renewables and some of the larger ones, which are the more costly options. So the idea is that we would first exhaust the cheaper options and then go in for the other options. And this is called the marginal abatement curve. When we look at the energy transitions, going out into the future, we've already seeing the electricity sector having a transition. We are shifting from fossil to renewables. We are changing the supply mix. We are going with solar PV and wind. We are improving the efficiency. In the transport sector, there is a moving away from oil. This is relatively slow. We had, due to the policies and due to the ports coming in. Most of the urban areas have moved to CNG. We are now moving to electric. There is a move for the hydrogen. We have biofuel and methanol. Also, there is a possibility that we can go towards public transport. We've also seen during COVID that, really speaking, do we need to have so much demand for travel? And of course, now we see a bouncing back where the travel and air travel has already increased beyond the pre-COVID levels. In cooking energy, we've made the transition. We are making the transition from the biomass and agricultural residues and which were fired in the chulas. We are making a transition to LPG, but LPG is still a fossil fuel and that has a CO2 element. So now the question is, going forward, can we think in terms of electricity-based cooking or modern biomass-based cooking or some other way where we look at solar cooking or some other cooking? And the cooking energy is, again, another very important thing that we have to plan for in our transition. In buildings, going away from the past system where we used to shut out the natural elements and then just close everything, have artificial lighting, artificial ventilation and cooling. We are now going to a situation where we are trying to have solar passive. We're trying to design buildings so that we use less energy and we can have net zero and energy plus buildings. Many such designs exist. So the idea is that each building can be what is known as a prosumer. You produce and you consume and you supply, and then there's a grid which is supplying it. So that could be another element of the transition. We can look at industry where you have low carbon industry, where you can produce steel, cement, aluminum with zero carbon. We look at efficiency, renewables, carbon capture and storage, and next generation processes. All of this is technically possible, but today some of these may be not cost effective. And going forward, this could be a way in which we can think of an energy transition. One of the other issues in the energy transition that you need to look at is that we've gone, for instance, we've gone very strongly into solar, but a lot of our solar happens to be, we've gone for global bidding, and a lot of our solar happens to be from a few countries. And if you just see the solar PV manufacture, the top 10 global companies, you will see that they are all predominantly from a few countries. And this is something the government is trying to correct by having these production-linked incentives and to try and see that we actually become cell and module manufacturers and we can have indigenous capacity which is cost competitive. So when we talk about net zero, there are many different ways, and you would have read about these. Net zero can be computed in different ways. The first way is when we look at only the carbon dioxide and the economy, the annual CO2 emissions, and take that to go towards zero. That's one way of computing it. The second way is where we consider not just CO2, but we consider all greenhouse gases in terms of CO2 equivalent and the economy in terms of the annual. However, if you look at the economy, we are also importing goods and exporting goods. So there is an impact of trade, and this can be also computed in terms of embodied carbon. So this is a third way of computing a net zero. And the fourth way is when we don't just look at annual, but we look at cumulative emissions, because as you know, the CO2 and the greenhouse gases stay in the atmosphere for a significant proportion of time. So whenever you are doing a calculation and you're doing net zero, please define how we are going to, on what basis you're making these calculations. I'd also like you, when you are looking at things, there are many, we talked about, we've had these lectures on the input-output models. There are very simple energy calculators, which are accounting models. And I would like you to take a look at some of these. These are all public domain. And the NITI Aayog created the IESS 2047, and some of our researchers were involved in updating that. You will see that all of this started where you have various possibilities for scenarios up to 2050. The first calculator was developed for the UK, and then you had calculators developed for many different countries of the world. And you can take a look at some of the calculators, the UK 2050 calculator. It has a nice visual interface. All the actual things are done on Excel. And these Excel sheets are available for free download. So it's all transparent. And after that, this is linked to the front end. So if you want to really work where you make your own numbers, you should work with the Excel. If you want to just see what ifs based on the assumptions made by the model, then you can work on the front end. But for an analyst, you should actually work with the Excel. The Excel is linked through a Python interface, and then it goes, you have this front end, which is this design. You can see in all of this, what happens is you start with a base year, and then you have a target year. And for the target year, you can define how you would like to look at the future of the country, make some assumptions, then see what happens in terms of energy, CO2, and growth, and then see whether these are consistent. So this is the advantage of the calculator. There's an European calculator, and you can look at each sector. You can look at the supply, you can look at the demand. This is a very nice tool for you to be able to play with and see what possible futures are there. This is a global calculator. There's also a Mackay calculator, which has been developed by David Mackay of Cambridge University. All of these things are available for free download, as well as you can use. This gives you, so essentially what happens is that you have various, there are many papers which talk about net zero scenarios. The first thing which you understand is a scenario. What is a scenario? And I'll come to that. Let me just define what is a scenario. A scenario is a possible future state of the system. You need to realize that there are many different ways in which we can go to net zero. And there are many different trajectories that we can follow. So to give you an idea, this is something that we did. We took the projected value of CO2 emissions, which the actual value in the past. And if we just project that, we see a certain level of growth. If we just take in the last few years, the way in which this has been reducing, we get the next curve. After that, we can decide when we want the CO2 emissions to peak and when we want to get to net zero. And accordingly, we could have multiple trajectories. For each trajectory, we can then define a pathway of how much renewables, what happens to each sector, what are the policies related. So one of the things that we must realize is we've given ourselves some time. India has decided that 2070 will be the net zero year, which means that we will take the energy sector that we have today and take it to net zero by 2070. We have this time frame from 2024 to 2070, and we can have multiple different trajectories depending on the trajectory that we have. And this will depend on how technologies shape, how the economics shape, but we can create alternative models of the future. We can use the models and the software available to define different possibilities and see what ifs. And this is part of the analysis that we can do. You have already studied, and you must have seen the commitments that we made in Paris, and subsequently in Glasgow, we've made much larger commitments, and we are on our way to meeting all these trajectories. You can see also very clearly that the share of renewables installed capacity has grown very significantly, and even renewable generation today in our electricity sector is now very significant. It's more than, it's about 11-12%. And you can see the difference, the share by capacity, of course, being much higher than the share by generation, because renewables by their very nature have an intrinsic capacity factor. And just to give you an idea, we have, in the electricity sector, there's a load demand profile where you have, we have the morning peak and the evening peak, and in between a reasonably flat load and then it goes down. And we can see that over time, the demands have been increasing, and GDP and electricity consumption per GDP has also been increasing. The growth of the solar and wind and hydro, solar and wind have been very significant. Now, as we go for the transition, one of the things that we need to understand is that when we are going to have more solar and wind in our mix, there is an issue in terms of the matching the supply and demand, because as you know, when in the morning hours, when the sunshine insolation increases, that's when the output will increase. And when the sun, just after, in the evening, towards the evening, this PV output would decrease. So we created a methodology by which we projected with different levels of solar and wind in our system, what happens to the load profile. So we estimated, this is called the duck curve for the California, based on the analysis which was done for California. So the whole idea is that as the solar increases and the rest of the system, the demand would have to decrease. As the solar will decrease, you will have to ramp up the rest of the production. So this is how we need to plan. And beyond a point, as we keep adding more and more solar, if we add more PV, each unit of electricity that we provide from PV will not be used during those sunshine hours. So it will be stored, it will have to be stored and used in the night or in another location time when the solar is not available. And this involves, so you can actually see, as you increase the share of solar, this is done through the simulation, you see a particular point where all the units, the additional units are going to have to go to storage, which means that this will involve an additional cost. So we've also discussed, and you will be seeing this during this time, there are a number of policies that have been, that India has tried for enhancing renewables. And we will now look at this. I'll ask Pratik to tell you a little bit about we'll talk about one of the new policies which has been done for rooftop solar. So with this, I just wanted to give you a quick sort of perspective on the energy transitions and what it means for India. So over to you, Pratik.
Yes, sir. Let me share the screen. Is it visible?
Yes, it is.
Okay. So, if you may know, India has been doing a lot in solar since 2010. It launched National Jawaharlal Nehru National Solar Mission. In 2015, it revised the targets for the mission, and from 20 gigawatt, it was upgraded to like 100 gigawatt by 2022. And now we are talking about 450 gigawatt for renewables. So in that, there are like two ways you can install big plants. Of like megawatt and gigawatt scale, and there are the small system rooftop systems. So earlier there was a target of installing 40 gigawatt capacity of systems by 2022, and now government has come up with a new policy to operationalize the same. So in 2017, Ministry of New and Renewable Energy started a specific scheme for grid connected rooftop PV system. In 2019, it was again revised. The phase 2 of the scheme was started, and now there is total revamp of the scheme. So the target capacity of 40 gigawatt has been planned, out of which 30 gigawatt is expected to come from, expected to come from a residential PV system, and the subsidy has been increased for to 60% for first 2 kilowatt. For third kilowatt, it is 40%, and beyond that, there is no subsidy. So, and for group housing societies, the subsidy is limited to 20% for, and it depends on how many number of houses are involved in that group housing society. So how this thing will be executed? Consumer can directly apply on national portal. So government has uh, brought most of the stakeholder on and connected them to the portal, like Discom and banks and installers through the empanelment, and then consumer can directly apply on the portal. DISCOMs will look for the net metering installation and update the about the installation process on the portal, and then DBT has been introduced in the rooftop PV segment. So whatever subsidy you will get, you will directly get into your account. And to fast track the process, single window clearance will be given for C&I sectors through the national portal. Talking about financial incentives, 75,021 crore rupees have been allocated by the central government, and banks have been asked to offer a loan. Banks have been told to offer loan at maximum of 0.5% above the repo rate, and then we will see the operational guidelines of the same maybe in coming months. And for MSME, the interest rates have been lowered, and for urban local bodies and panchayats, there is a push for having model villages and model towns for this rooftop PV system. Promoting domestic manufacturing, you might have heard about PLI scheme, production linked incentive for PV modules. So made in India solar cells and modules are being promoted for this overall installation. And one model solar village is planned to be developed in each district through this revamped schemes, and mission mode deployment is expected, rather than the earlier it was just a scheme under the ministry, but I guess this is now going to be one of the flagship mission for the government. So these are the provisional things that government has come up with, but the more detail, more nuances and operational guidelines we will see in the coming months. So yeah, this is what I have at the moment. If regarding the subsidy, this is what the Ministry of New and Renewable Energy has published recently. For 2 kilowatt, it is going to be 30,000 for first 2 kilowatt, 30,000 per kilowatt. For third kilowatt, it is 18,000, that is 40% and of the benchmark cost. And beyond 3 kilowatt, there is no central finance assistance. And then for group housing society, it is 18,000 per kilowatt, capped for the at 3 kilowatt per house rating. Yes.
So
So yeah,
what you can do is, based on the estimation that we have of capital costs, you can then see that with this incentive, what is the final cost of generation, and how does it look like from the point of view of the homeowner.
Yes. So maybe a project finance kind of calculation, whether it is financially viable for the.
Yeah. So are there any questions on the YouTube channel?
Prabhat?
No, there's no question till now.
Okay. So if not, I think we can just give you an idea of the, we're going, the final exam which is conducted. Typically, it's a simple pattern which is very similar to the things that you have done during the course and in the assignment. There are 30 MCQs and each one has 2 marks. There's no negative marking. And then there are 8 questions which are more long answer type, where you have to do the calculations, and each one has 5 marks. So that is essentially the pattern. And if you have any, as you prepare and you look at the things and you are preparing for your exam, if you have any queries, please do post it on the group and we will respond to that. The course gives you an overall way in which you can analyze resources, economics, and the environment, and you can actually use the tools and techniques that you learn in the course to analyze any large system. When you think in terms of, now we are now talking about the hydrogen mission. This is a mission which is being launched by our government now to look at green hydrogen. You can see under what conditions will a hydrogen vehicle compete with an electric vehicle. And you can look at how does a hydrogen vehicle car, how will it compete with, compare with, let's say, an IC engine vehicle running on petrol or on diesel. And you can look at it in terms of costs, you can look at it in terms of energy, you can look at it in terms of the environment.
Okay, so
Okay, so if there are no questions or comments, I think we can close the session unless Pratik, Prabhat, you, Sandeep, if you want to just add anything.
no, I guess I don't have anything. Just the point that we have an exam on 27th April 2024. Just like if people.
27th
Then-
April is the date
Yes,
of
yes,
exam.
yes. Okay,
Yes, same, same. So no input from my side.
Okay.
okay.
Same, nothing from my side.
Okay. Thank you. All the best for your exam. Yeah. You can close.
Yeah, we can close. Sandeep ji, we can close.
Okay, okay.